of AH, which gives the answer TAH 0.5J minus square root of 3 by 2K. As we know also, sigma MC is equal to sigma R cross F is equal to 0. So let's take the cross product of R and F, which gives the answer 300 R dy K minus 300 R dz J minus 1 4 4 times 0K plus 100,000 I minus 25 TAH K minus 25 square root of 3T AH J minus 125 square root of 3 T AH I is equal to 0. As we know, sigma m is equal to 0. So about each coordinate, the direction of each unit vector equating to 0. So first of all, let's equate the I component to the 0 from the above equation. So here we need to gather all the I components. So in this equation, this is the I component term. Then this is the I component term that we are going to equate to 0, and from that we can get the result as
Call this
TAH
omega,
is equal to
which is the angular velocity for the
461.88
rotor,
Newton.
and for this
By equating the J component
precision
to 0,
velocity,
we
we
will
call
get the
that
result R
big omega.
dz
So
is
now
equal to
if we
minus
want to figure out the upward force exerted by the pivot, we'll
66.667
see that
Newton.
this rotor
And by
is
equating the K
rotor has
component,
a
we will
mass,
get the
and
result
the
R
gravitational
dy
force is
will
acting
be
downwards.
equivalent to 505.157
And since the rotor is not
Newton.
going down, it's balanced. So that means through the pivot point,
Now
there will be an equal and
we
opposite
know
force which will be balancing this
RD
mg,
is
or
equal
the
to
weight of the rotor. So that
R
means
dxi
the
plus
force acting
R
on the
dyj
pivot point will
plus
be, let's
R
say, Fp,
dzk.
which is equal to
So
the
by
weight of
putting the
the
values, we will
rotor,
get RD as
or let's call the total weight, which is
505.157 J
0.165
minus
kgs times
667
9.8
K Newton.
meter per second squared, which gives us
But also we know the
1.62
sum of
Newton.
forces in the x direction will be 0.
Now in
So
part
I
B,
can
we need
write
to
sigma
find out
fx is
this
equal to
omega
0.
quantity right here.
And by
So we know
summing all the
that
forces in the x
precision velocity
direction,
or precision angular velocity
which give the
omega
result
is equal to weight times
Rcx is equal to
r.
0 Newton.
R is the radius
Similarly, we can
divided
take
by I
in the
over
y
omega, where
direction.
I is
So
the
Fy is equal to 0,
moment of inertia.
which leads
Now
to the Rcy is
we
equal
don't
to
know the
minus
omega. We need to figure out that from the problem.
336.079
So in the
Newton.
problem, it says that the gyroscope is
Similarly, from the
precessing
z
in a horizontal
direction,
plane at a rate of 1 rev in 2.2
we will
seconds.
get
So omega will be 2 pi
Rcz is equivalent to
radians per
466.667
seconds, which
Newton.
is 2.856
Now also we know
radians per
Rc
second.
is equal to Rcxi
Now
plus
we can solve for
RC by
this
J
omega
plus
or the little omega, which
RCZ
is
K.
W times R over
Now putting
I
the values of this
times
Rx, Y and
big omega,
Z, we can
and we
get
know all the values.
minus
So this W is
336.097 J
0.165
plus
kg times
466.66
9.8 meter per second squared
So this
times
is my
R, which
RC.
is 0.4 meter divided by I is given as 1.2 times 10 to the power minus 4 kg meter squared times omega or big omega, which is 2.856 radians per second. And that gives us our little omega as 189
Welcome to Ask and Learn.
radians per second.
Hi everyone, this is the problem based on
1.8
kinematics
times 10
of
to the
rigid
power
body.
3
Here it is given
revs
the
per
boom
minute.
AB as shown in the
Now for
figure.
part C, we can actually
The
explain
length
part
of
C
boom
in this
AB
diagram.
is
So if we
decreasing
look at the figure from above, we'll
at
see
the
that
rate
torque will be in the direction of the precision. So this is the precision velocity. So torque will be, so let me actually draw
0.2
it here.
meter per second.
So we have the rotor
And
around
boom
here,
is being lowered
and
at
then
constant
there's
rate.
it's rotating
It is lowered
along this axis. So the torque, if we look from above,
at
the
constant
torque will
rate
be
of
along in the direction of the precision. So maybe the like tangential
0.08
direction
radian per second.
at each point.
We have to
And then
find
for L, this
A
will
part
be along the axis of the
velocity
rotor
of point
away
B
from the
as
pivot
shown in
point.
the
So if
figure
this is the pivot point,
and
then L
acceleration
will be
of point
directing
B.
this
Such
way.
as carbon
So this is
dioxide
torque,
allow
this
light
is
to come
L,
in really
which will be
well.
away from the
They're very translucent,
I'm
but then they
pivot point,
absorb
drawing a rough
that,
and it will be
that
along
light.
the axis of the
And
rotor.
because
boom. Its
we're
length is
interested
decreasing.
in
So,
having a
the
stable
rotor
climate,
This
it's
is
something
A
that we're
point,
paying
this
attention
is
to.
B point at an instant.
What's the
like
source
this,
of
so
this
that
increase?
means the
This
axis
is
this
not
way.
not a
So
debate.
that's why
This angle
Over the
is
last
given
200 years since the
away
Industrial
from the
Revolution,
pivot point.
humans have
Thank you.
theta is equal to 30
drastically
degrees.
and exponentially increased the amount of carbon dioxide that we put into our atmosphere through the consumption and combustion of fossil fuels. There are other natural sources
Here's
as
the
well that do
solution.
include things like forest fires and volcanic
Velocity
activity.
of
Welcome to
But the
Spring
vast majority
LIB.
of carbon
So in
dioxide
this
Coinciding.
comes from
problem,
the
angular momentum
combustion
will
of
be
fossil
conserved.
fuels.
So in terms of
and
rotational
the combustion
motion,
of
we can
fossil
write
fuels
angular
still
momentum
accounts
as
for
I
the
times
generation of
omega.
about
Beat on the
80%
And
of
since we
of
have
our
two
energy
different
production
scenarios,
globally.
one
So
is
it's
when
something to pay attention to.
the star
Good luck
is
studying.
massive, and then the other scenario is when the star is collapsed. So we can denote them into two different entities. So one, let's say when the star is massive,
Welcome
the
to
angular
Solarify,
the
the
momentum
place where
is
learning
I1,
becomes simple. If you
and
struggling with
the
homework,
angular
assignment,
velocity
or doubt
corresponding to
in
that is
subjects,
omega 1.
don't worry, you are in the
So
right
from the
place.
meter per
conservation of
second
angular
in the
momentum, we
direction.
can set
So
that
the world
equal
gets
to
about
Down to the horizontal
80% of
line.
its energy
I2
from
times omega
this
2, where I2
broad
is
group
the
of chemicals we call fossil
angular
fuels.
moment of
It's
inertia
everything
when the star
from
is
natural
collapsed.
gas
Similarly,
to
omega
oil
is
to
the angular velocity
petroleum,
at that point.
Shell.
just
And we know for a
essentially
solid
carbon
sphere,
that's
I
been
is 2
compressed
over
by the earth.
5
In a conductor, the
That
Velocity
came
of
from
squared.
biomass a long time
And we
ago.
have R1
So there's
for
no charge on
I1
the
and
inside,
R2
nothing's
will be
reduced.
for
This is
E
I2.
must
to
also
B.
be 0 here.
So we can
Substitute
write
the value.
B less than or less than C,
2
we're in
over
this first
5
ordered region.
m
Our inner shell,
R1
welcome to
squared
Solarify,
here
We
the
take the
place
x
where
component
learning
of
becomes
it,
equal to
charge
2
if
over
you're
5
struggling with
m
homework and say
taking
that
right
or
to be
doubt
what
in
squared
subjects,
we will
times
get
omega 2.
you are in the right
Point
So we
place.
can get
four
rid
That's
of
2Q.
this part,
So that
For
means
this
that the
question, we're
electric
given
field
a
can be
molecular
written as
orbital
and then we'll
calculation
have
for
in terms
H2.
of
omega
To
2,
prove about
is
this,
to be
they've
equal
actually
to
put
writing
in
it like that.
energy
point
we need to
zero
figure out
into all the
that
orbitals.
which
This
is
is
But
just
equal
point
to
pi,
zero six
omega
six
1
qualitative
times
epsilon 0,
highs and lows. They
R1
have
by
action
and the
and
total
R2
opposition.
charge
meter per
inside,
second.
which
So
is
the
2Q.
and
energy
here omega
And
1
along
is
Divided by
is going to
r
correspond to the
squared.
given
energy of
as
an electron in that orbital.
taking
one
this direction
So
to
the
be
first
rotation
part
positive
asks us about the
per
ionization
30
energy
days.
.4
So we
of
can
And
convert that
hydrogen.
to
let's see
radians.
now.
So we'll
C
have
less than
C
R less
minus
than D. So
And
that
we
means
just
how
need to
it
look, you don't need
divided
this
by
molecular
so you
orbital
will
picture
get
here.
So
You
minus
just want to
which means
look
our
at a
region
single
section.
hydrogen
and
atom.
the
So that's
It's going to
going to
give us
be
the
electric field must
ionization
be
energy in
equal to
terms of
0
joules per
here.
molecule. So this is
1,400
just a
Because
unit
to
of
convert
measure.
seconds
an
per
equation to
day.
the
We just
electric
take
field,
This
the
is
net
two
electric field must be
VX
0. I plus
times
2q
10
here.
to
times
So I need
R1
minus
is
2q on this
7
intercept.
times
By
10 to the power
joules. To get
5
into kilojoules,
kilometers,
we'll need
general.
to divide that by
and R2
It's
is
1,000.
still
16 kilometers.
to 0
And to
there.
get
And
it
this
into
angle is
kilojoules
alpha.
per
And
mole
we take a
instead of
square,
First we
kilojoules
so
per
that
find
mole,
gives
the
us
Finally,
we'll
magnitude
need to
outside
multiply by
times
alpha vector
of this
square
system,
of x component
what you have to do is take the total
times
coordinates
10
for
raised
plus
to the
the
2q
square
minus
of y
2q.
component and
So
x
q
square
goes
If
square
we do that,
minus
we should
2q.
get
And we get E
A
equals
an ionization
1
energy
magnitude
of
of
about
velocity at B point having the value
times minus
1,313
2q
kilojoules per mole.
B
over R.
520
So based on this
meter per second
calculation,
in
the
the direction.
ionization energy of H2 in kilojoules per mole. We
All
will
right, so
add
let's
the
get into the
other
components of
here.
UA.
So we're going to do
Here's a
a
top
very
view of
similar
the
thing,
setup.
except instead of
Here we
using
see that the bar is
2.18, we'll
is
use
at this end,
2.51
and
since that
the
orbital
bug
is lower
is
in
here,
energy.
C.
and this is the table.
Looks
So
like
the
it
bug
is
Another thing to note is
jumps
that we're going to be ignoring the
perpendicular
minus sign.
to the pivot point.
We want to know that
and then the negative
This is
y
the
direction
direction.
add
0.75.
So there
So
are two locations that
negative
we
to
should
get it
know.
to
to
zero.
Now,
So
we're saying that
the energy of the
is
orbital is
defined
negative
as
2, then we had to add
J.
2 to
like
get it
You
up
can
to
get
AS,
our
zero.
little
as
graph
defined as the
here.
object bug, and
So
B
If we do the
for
exact
B.
same calculation as
So
in part
MB
A,
corresponds to
which
the
is
mass
Okay,
of the
one,
bug,
you see the
similar to
ionization
B
energy
corresponds
goes
to
up
the
to
mass
about
of the bug.
1,500
And
now.
when the bug
Is,
jumps
let's
this
see
way,
here.
then
Now we
an
want
X
to look at
component
the
and a
bond
Y
energy
component.
in
angular
H2.
The X
either
So the
angular
bond
component
energy is the
is
difference
So
between the
I'm
energy
graphing
of
it
the
Cos
two
phi
electrons
r
in the
we mark that
hydrogen
as
atoms
omega t.
and the two electrons when they're in
Now,
H2.
also we're given
And
the
again,
length of the bar,
obviously,
which we call
consistent
r.
And
side
the
information
Y
per
So
component
if we
molecule
apply
in
would be
kilojoules
two
per
side
mole.
momentum here,
So we need to know the
this
difference here.
collision,
That's
the
going to
angular
be
both
momentum
positive.
is
2.51
zero because the system
It
was
looks
at
like
rest.
minus,
But after the angular,
Some
after the bug
2.18.
jumps, there will be some
And that's still
non-zero
going to
angular
be times
momentum,
10 to the minus
and we
15.
can calculate that
And then we want
using
to
this
double that.
expression,
or more.
where
And we want to double that because there's two
The-
electrons
When you
here.
graph it, there will
Each
be
one of
two
those
solutions.
gets
You
lowered in
can
energy by
choose
that.
the
linear
physical
momentum,
solution.
and we multiply
X
that
So
by
component.
the
in this
radial
instance,
vector.
it will be
So
And
that
now we
gives us
just
the
do
angular
what
momentum.
we've normally been
Since
doing.
Is
omega
negative
b
We're
is
going to
going in the
divide by
opposite direction,
1,000
so we put a negative sign
and
after
multiply
that, and
All right.
by
we
there we go.
6.022.
Okay,
The
so now we
raised
can
to
look
angular
Y
at the
momentum
parts
component
that
is
due to
zero.
a
Of
pivot
Gadra's
or
number
due to the
around
bar,
these shells.
which is ib
And we see
times
that the bond
omega b,
energy
where
is
ib
about
is
The
the
Y
momentum
component is
in
negative.
direction
All
for
right,
the
The
just a
bar.
interceptors
minute.
of our small.
So for
Now,
Gadra's
we
molecule,
still
it wants us to
since
The
the
look
X
bar is
up
limited
component
to 1
is
and
two.
Inside of this guy,
the
so
we
ib
have
will be
acceleration of
1/3
in
mvr
this
squared.
guy must be zero.
So from
it
here,
wants us to look
And
at the bond
the Y
energy for
component
hydrogen
will
is
in table
negative one.
Must be the
5.3.
total
equate
charge on the
these
shell
elements
plus
before
2q.
That
collision
And
bond
there is
energy
no
and
is
since this part is zero, so
Okay.
this
Let's look at the large one.
we have 1 times
And then what's the
Okay,
All right.
source
So it gives
of
us
this
is equal
increase?
to
So,
zero.
It almost seems like
Four
it's
times
we get
for
omega
most people
t
what it is. That
1.7
carbon
So how's it
dioxide
calculated
equals
bond
5 times
energy
10
in the
to the
direction
well,
as
in
it relates
table
to
4, we got
climate change,
80.
because
Then
carbon
we're given
dioxide is a greenhouse gas.
and the
So
percent
I
difference
need
is
to
going to
use
be
So all we do here
A
is we
Z,
substitute
which is
it
going
IC
to be
and we can
3
simplify that
Z
expression and
minus
solve for
UA.
2 radians per second.
So
And
2
then
minus
and then that
0.015
would
divide
give
by
percent
and
difference. We have to put that
radians per
over
second
Minus
A.
2q
the
right
whole.
here.
And
So that's
three
Then
is
that's
the
minus
minus
1
1
J.
J.
we get a
So
percent
Sounds like it's
difference
zero.
of
A little bit
divided by
into
100
light and reaches out.
about 9%
Wait a
difference.
minute.
So
now our
you
thing
say
and
you
three
know
is
is
the- and what the
so
study
Z
is
minus
It
X.
sounds like it's relatively
Oh,
limited
so
and light
So
and
now
that
we can
is
see
really
what
important
it
in that
is.
atmosphere.
Minus
And
now
two.
so we know there's water in the study, and the way that it does that is
sp is between sp3 orbitals. As we went through the drawing of these orbitals, they're all going to look something like this. Except the only differences would be are the difference which the asymmetry between these two is exactly. So for sp3 it's going to be very exaggerated. For sp it might be a lot So essentially, s orbital completely symmetric, p orbital like this completely asymmetric. And so the more degree p has in it, the closer to this guy, and the fewer p orbitals it has.
I'm just going to solve it for z.
And then remember the hybridization is correct. We need to add up the number of atoms and the number of orbitals together. And then compare that to how many orbitals So, for example, if we had something like this,
so it's going to be 6.63.
So let's determine
we have no lone pairs on carbon. It's got 3 singles rounded. So that means we need
The answer?
orbitals. That'll be 1 s and
The easiest question in this unit so far.
times the rate of 200, which is 3 meters. So we have 29.43 kilopascal. For pressure B, we have gamma rate of we have 1000 times 10.81 times 2, which is 19.60
Why are scientists
kilopascal. So now we can determine the
atmospheric carbon dioxide levels?
For FA, we have
What's the source
Start this
of
problem
volume
off
of
by
this
It
identifying
almost seems like
water
common
pressure.
for most people that
So we
carbon
have
dioxide
multiplied by the base, which is
as it relates to climate change, because carbon dioxide is the greenhouse gas. And in turn, we do something very specific.
which is equals to 265.57 kilonewtons. For FB, we have this row, we have 1 half times the
And
base
light reaches
final
us.
velocity
times the height times the length of the gate. So we
And
have
sounds
117.72
like
kilonewtons.
a
negative.
little bit
So we can do a
Back to
acceleration moment
baseline.
which is equals to 0,
We have a negative velocity.
and our
What this
velocity
does
is positive.
Time interval.
So we have
is travel some of that
264
within that atmosphere so that we can so that the water is in the way and the way that it does that is one way is just that the gaseous molecules
minus
in the
x times
atmosphere
4,
they
which is equals
are
to
really excited.
really happens to change
So solving first the x, we will get 46.60
Some
kilonewtons.
chemicals in particular allow light,
And we can
such
do
as
an
carbon
acceleration of
dioxide, allow light
forces
to move
horizontal,
really well.
which is equals to 0.
But then they
We
absorb
have
that.
264.87
And because
always
we're
minus
interested in having a stable climate, which is something we're paying attention to.
minus
minus
What's the source of this
96.6
decrease? This is
minus
not
2x,
none
which
of
is
this.
equals to
Over the
0.
last
So our
200 years,
dx
the
Now in this case, we already said that we started.
humans have drastically and exponentially increased the amount of carbon dioxide that we put into our atmosphere through consumption and combustion of fossil fuels. There are other natural sources as well that do things like forest fires and volcanic activity. But the vast majority of carbon dioxide
Here, this would be our mass
combustion of fossil fuels
Write that in.
and the combustion of fossil fuels accounts for the generation of about 80% of our energy production.
Divide the change in time.
Something
To
we're
identify the forces.
Solve for our force.
Here we have 5 unknowns, TAH, RBY, RPX, RCX,
So we've solved this
RCY,
algebraically.
and RCY.
Numbers.
The coordinates of the
Number
quantities are
46 kilograms.
Kilogram times
Final.
origin.
So the world gets about 80% of its energy from this
this case the negative
broad
is
what we call fossil fuels. It's everything from natural gas,
Our delta T
oil, to petroleum, just essentially carbon that's been compressed by the earth, and came from biomass a long time
equal
ago.
to negative 69 newtons. And again, this negative sign is significant here because it means we're moving away from the water. And there we go.
H is equal to 0 to 50. Now apply the equilibrium equation. First, we need to do
This question was given a molecular orbital calculation for H2,
so we can write
actually put in energy into all the orbitals instead of
VC is equal to
Question number 10. We have streams of water strike stationary turbine blades horizontally.
Yeah, corresponds to the energy of how much
And then what we are asked to find magnitude
So
of the
as
average
part of
force
that
exerted on the water by the blade. One key piece of learning from this problem.
and we just need to look, we don't need to
So that tells us the mass of water
just
per
want to look
second
at
is
the
right
atom,
30
they give
kilograms
us the ionization energy.
We're
H
going to
is
assume
equal
for our problem
This is
sake
just a unit.
this is all happening in 1 second. That's going to help us be able to solve it. Okay, let's get started. So we are given in this problem
As we choose to get into
the water has an initial velocity
and
of 16 meters per second. And when it strikes this blade, that a final velocity of negative 16 meters per second, moving in exactly the opposite
to
direction.
that you should get
And like I mentioned, we're going to talk about this
ionization energy of about
of 1 second.
0.5 J.
Per second that allows us to identify the mass
So
of
based
the
on
water
this
that's moving in that 1
calculation, this is
second.
ionization energy
30
of
kilograms.
H2 in kilojoules per mole. We
The
look
reason that we
at
want to use
H2
this
down here.
is because
Now we're going to do
impulse
a very
momentum
similar
theorem.
thing, except
Solve
instead of using 2.18, we'll use 2.51
We know
since that
impulse
orbital
momentum
is
theorem.
lower.
F
So let's
delta T
take the cross product of
Another thing to
I
note is that
and
we're going to be ignoring the minus sign.
which is the answer.
We want to know that we want to know the energy that we have to
300
add
Others are
to
unknown in this
get
minus
it to 0.
So we have
300
force times delta T
Negative, so we have to add
minus
divide delta T over. So that our force
So if we do the exact same calculation,
Final
part A
minus P initial
plus 1, you see the ionization energy goes up to
divided by delta T.
and now we want to look at the bond energy of
Mass
H2.
is
Bond
going
energy is
to
the
be
difference between the
30
energy
kilograms.
of
We
the
would define this as a 1
hydrogen
second
atom
interval.
and the 2 electrons.
Right out
25.
this portion though.
Square root of
Remember that
again,
momentum equals
obviously,
mass times velocity.
AS
Information.
So our momentum final would be mass times velocity final. Our momentum initial,
So we need to know the difference
velocity
here.
initial,
That's going to be
square root of
divided by delta T.
AS I
Both
is
back
equal
that out.
to
2.1.
Gives us force
And we
That's
have
the
to
mass
find
times 10 to the minus
so about each
Final.
coordinate,
And
the
minus
direction
initial.
of each unit vector
And we want to double that
equating
because there's 2 electrons.
So,
Each one of
first of
those
all, let's
gets
equate
lower
the
than
I
right now.
component to the zero.
Now we are ready to substitute numbers.
So here we need to gather all
And
the
now we
I
just do
components.
what we're
So in this equation, this is the I component,
Final is a negative
then
16 meters per second.
this is the I component that we are going to equate
Minus
to
the
the
initial
zero, and
velocity,
from there
which is
we
a
can
positive
get
16
And we see the
meters per
bond
second.
energy is about 390
AS
Our time interval of 1 second.
It wants us to look up
And we get an average velocity
the
by
answer.
equating the three components to
$960.
zero, we will get the result.
It wants us to look up the bond energy for
is equal
hydrogen.
to minus
5.3.
66.667 Newton. And by equating the key components, we will get the result.
It gives us an energy of 430.
505.157.
So how does the calculated bond energy compare? Well, it's in the number 9. We got 396.
That is
The percent difference
base
is
growth,
going to
sorry.
be
space probe has a rocket attached to it. Let's try with the other space. This retro rocket is fired to slow down the probe.
And then
We are being asked to find
and if we want
the momentum of the probe after the retro rocket ceases its fire. Okay. So let's start again
we
with
get a
what
percent
we know.
difference of
We know that
multiplied by
initially
100%, about 9%.
the space probe has 7.5 times 10
But also we know the
7
sum of forces in the x direction is equal to 0. So I can write
meters per
down
second
fx is
of momentum.
and by summing all the forces in the x
We know
direction,
that the retro
which gives out
flies an average force
Rcx is equal to 0.
0.
So that means talking
Similarly,
about
we can take in the y direction. So
Now, this is where the little trick is in this problem. You have to read in, read between lines a little bit. In fact, there is a retro rocket, which means it's going to be firing in the opposite direction of motion, which is then defined here as positive because
from the z
of the
direction,
rocket.
So for SP3, it's
So
going to be very
motion going forward is
exaggerated.
positive, anything working against
It
it
might
is negative.
be a lot.
This force that the retro rocket is applying is negative.
So essentially, you know, an S orbital, completely symmetric, P
Applies
orbital like
negative
this,
force in a time
asymmetric.
of
And so the more degree P it has,
They're
the
asked
closer it's going to
what
look
is
to
the
this
final
guy.
momentum
And
of the space probe.
the
Set
fewer
down.
P orbitals it has,
So let's look at our impulse momentum theorem.
now putting the
Next
value
slide.
of Rx
hybridization scheme is
Well, that
correct.
happens
It is going
during
to add up the
minus
number of atoms
change
in
in
the
momentum.
total electron
0.097 G
together.
force
And then compare that to how many orbitals it takes to get to
.466.6.
Final minus
for
momentum
example,
initial.
had something like this.
In this case, we are looking for momentum final. So we're going to add over momentum initial.
We have no lone pairs on carbon. It's got 3 things
Plus.
around it. So that means we need to have 3 orbitals. That'll be 1s and
Equals our final momentum initial. Now we can plug numbers in. So negative 2.0 times 10 to the 6
Hi
newtons.
everyone, this is the problem is
Force is zeroed by the retro rocket.
Give it
Done.
the whole
12 second interval.
axle of the figure.
Add that to the initial momentum. Space probe
Chapter
had
7, why are scientists concerned about
7 kilograms
atmospheric carbon dioxide?
per second.
And then what's the source of this
Add
increase?
that all equal.
It almost seems like common sense for most people that carbon dioxide is an important issue
Lower
as it relates to climate change because carbon dioxide is a greenhouse gas.
Now again, in this
That
problem,
term means something
it
very
was
specific.
more about
So we were
understanding where the negative sign is. Negative sign is the retro booster in the rocket. Let's make sure you catch that one. That's why.
and the light reaches us. And the green is the atmosphere extends like a cable a little bit into
Acceleration of I'm just
and what this
going around
does
sketch. This is the goal.
is trap some of that within that atmosphere so that we can live, so that our water is liquid and all that kind of stuff. And the way that it does that is a couple different ways. But one way is just that the gaseous molecules in the atmosphere, if they get thermally excited because of UV radiation coming from the sun, they'll bring on that heat. That allows us to live. Some chemicals in particular allow light to, such as carbon dioxide, allow light to move really well. They're very translucent, but then they absorb that light. And because we're interested in having a stable climate, something we're paying attention to. What's the source of this increase? This is not a debate. over the last 200 years since the Industrial Revolution, humans have drastically and exponentially increased the amount of carbon dioxide that we put into our atmosphere through the consumption and combustion of fossils. There are other natural sources as well that can include things like forest fires and volcanoes. But the vast majority of carbon dioxide comes from the combustion of fossil fuels, and the combustion of fossil fuels still accounts for the generation of about 80% of our energy production. So, something to pay attention to.
The city of home.
Come to solidify. The place where learning becomes solar. If you struggle with homework, assignment, or doubt in subject, don't worry, you are right.
So the world gets about 80% of its energy from this broad group of chemicals we call fossil fuels. It's everything from natural gas to oil to petroleum, just essentially carbon that's been compressed by the earth. That came from biomass a long time ago.
Solving part of this problem. So using conjugation in the item here, I can write using conservation of angular momentum, I can write the expression as
So the first part is about the ionization energy of hydrogen. And just like the work, we don't need this molecular order.
on further simplification,
We'll look
we
at
can write
the
it as
atom, but it uses ionization energy in terms of
it is equal to IT by ITP multiplication omega t, which is equal to, so this value will be equal to 1 by 2 m r squared by 1 by 2 m t r squared plus m p r squared multiplication of omega t. So finally on further simplification we can write it as omega tp is equal to mt by mt plus 2 mt multiplication omega t. So it will be equal to 120 by 120 plus 2 multiplication 70 kg multiplication 3 radian per second. So you will get the value as 7. Sorry, it is equal to 1.3846 approximately 1.385 radian per second. Now I will simplify part B of this problem. So in part B I will use the formula KET is equal to 1 by 2 IT omega t square. It will be equal to 1 by 2 multiplication 1 by 2 mt multiplication r square multiplication omega t square, which is equal to 1 by 4 mt r square multiplication omega t square, which is equal to 1 by 4 multiplication 120 multiplication 2 square multiplication 3 square. So it will be equal to 10803. Now I can write the value of kinetic energy Tp, kinetic energy Tp is equal to 1 by 2 ITP omega Tp square, which is equal to 1 by 2 multiplication 1 by 2 mt multiplication r square plus mt multiplication r square omega Tp square. So this value will be equal to 1 by 2 r square multiplication 1 by 2 mt plus mt multiplication omega Tp square. So on solving it further, it will be equal to So this value will be equal to 1 by 2 multiplication 2 square multiplication 1 by 2 multiplication 120 plus 70 multiplication 18 by 13 whole square. So finally you will get the answer as 498.460. Now friction does work. Friction does work. Friction does work. Friction does work negative. So friction does work negative. Negative work is done by the friction, increasing parachute velocity, increasing parachute velocity. So if he falls off the table, energy is lost to his gain. So I can write he falls off the table, energy is lost, energy is lost to his gain, I hope you understand.
Percent difference we have to put that over the whole, so that's that 4. So we get a percent difference of multiplied by 100 put into percent, about 9%.
Welcome to Spring LIV.
On solving it, it is 2.05 meter per second square. And it will be in the direction. Theta is equal to 10 inverse of 0.08513 upon 0.004926.
He's talking again about S-P
down to the
orbitals. It's we want to include a drawing of these orbitals. All gonna look something like this. Except the only difference will be for the degree to which the asymmetry between these two lobes is exaggerated. So for SP3 it's going to be very exaggerated. For SP it might be a lot so essentially, you know, we can take an S orbital, completely symmetric, a P orbital like this, completely asymmetric, and so the more degree P has, this guy, and the fewer orbitals it has, the closer.
Rules without sliding.
And then how do you determine if the hybridization scheme is correct? We simply need to add up the number of atoms and the number of lone electron pairs and all together. And then compare that to how many orbitals it's mixed together. So, for example, if we had something like this,
And in part B, we need to find out 150 millimeters. We know that this is
At that, so that this
if no lone pairs on the
equal
carbon,
velocity.
it's got 3 things around it, so that means we need to have 3 orbitals, that'll be 1s and 2
radian per second
so sp2.
in counterclockwise direction. Angular acceleration 2 radian per second square in clockwise direction. Calculate acceleration of
Chapter 7, Section 4. Why are scientists considering increasing atmospheric carbon dioxide levels? And what's the source of this increase? It almost seems like common sense for most people what it is, that carbon dioxide is an important issue as it relates to climate change, because carbon dioxide is a greenhouse gas, and that turns into something very specific. So we live on, and
this is J cap.
somewhere on space, and the light reaches us, and the green atmosphere extends like a halo, a little bit into
You start solving it.
And what this does is traps some of that heat in that atmosphere so that we can so that water is liquid and all that kind of stuff. And the way that it does that is over here. A couple different ways. The one way is just that with the gaseous molecules in the atmosphere, that they're thermally excited because the radiation coming from the sun, they'll hold on to that. That allows us to live. Some chemicals in particular allow light to, such as carbon dioxide, allow light to come in really well. There's transmission, but then they absorb that. And because we're interested in having a stable climate, something we're paying attention to. What's the source of this increase? This is not a debate. Over the last 200 years since the Industrial Revolution, humans have drastically and exponentially increased the amount of carbon dioxide that we put in our atmosphere for consumption and combustion of fossil fuels. There are other natural sources as well, things like forest fires and volcanic activity, but the vast majority of carbon dioxide comes from the combustion of fossil fuels. And the combustion of fossil fuels accounts for a generation of about 80% of our energy production. So something to be
Come to solve. Live where learning becomes hard. If you struggle with the important sign, the doubt in subject, don't worry, you are in the right position.
So the world gets about 80% of its energy from this broad group of chemicals we call fossil fuels. It's everything from natural gas to oil to petroleum, just essentially carbon that's been compressed that came from biomass a long time ago.
There are three Of course, I begin by the diagram. So there are three sources. Of course, I begin by the going negative 2 degrees, it's only negative 1 foot. Alright, the Z direction is going down 4 inches. Over the square root. 1.5 square. That's 1 square. That's 4 square.
And again, obviously, information.
Okay. That gives me 6.84 I'll put negative 1 in the numerator.
And we want to double that because there's
Radians per second is
each one of those.
6 today. Negative 4 in the numerator.
And now we just do what we normally been doing. Divide by 1,000.
F.
And raise
Now the denominator becomes, well, first of all, FAC, according to the book,
it wants us to look up
40 pounds. So it's 40 times.
It wants us to look up the bond
Now in the denominator, I'm putting
that bond
acceleration A. 12.98.
negative 2 sine 20
So this gives us energy
squared.
of 430.
Plus
That's what
2 plus
Calculated bond energy.
20
Well, it's
squared.
the percent difference, which is going to be
Plus 4 squared. Alright, so the numerator is negative 2 sine 20.
that would be the difference. Percent difference is
Negative 4.87. Now I'm going to put the 2 plus 2 cosine 20 in the numerator.
kilogram per 27.6 horizontal reactions at each C and makes a block.
And now -4.
Free body diagram of leak tanking. Let's call this as point C.
Going to add those together to get the resultant.
And we have y component of
6.84 minus
these are the reactions.
4.87.
The reaction of stop block, let's call it as the
1.97I.
water pressure is set right axis.
27.6 minus
P3 it's going to be very exaggerated.
Pressure
As P it might be a lot.
23.
Sorry, start here for this question. So using
This orbital completely symmetric. It's the orbital like this. Asymmetric. Degree. P it has this guy. And
angular momentum.
the fluid orbital that has
And I'm still not done.
I can write the expression as
information speed correctly.
LT is
The
equal to
number of atoms and the number of electrons
pressure
together. And then compare that to
omega t
Equation.
IT
So,
1000
omega t
times
on the simplification you can write omega tph
kilopascal. So now we can determine
IT by
you have no lone parent on carbon.
for
It's
Fa
got
we
equal
have
and rounded.
omega
That means
t
we need
volume of
three
this
orbitals that'll be
water
1
pressure.
S and 2 X.
So we have 1 half
1 by
divided by the base, which is 10
m r square by 1 by 2 m t r square plus
which is
m
equals
p
to
r square multiplication of
264.37
so
kilonewtons.
finally on other simplification you can write it as omega tp is equal to mt by mt plus 2 mt multiplication omega t is equal to 120 by 120 plus 2 multiplication of 70 kg multiplication of 18 per second. So you will get the value as 7.7. Sorry, it is equal to 1.3846 approximately 1.385 radian per second. Now I will simplify part B of this problem. So in part B, I will use the formula KET is equal to 1 by 2 IT square. This is 1 by 2 multiplication 1 by 2 and multiplication R square multiplication omega t square, which is equal to 1 by 2 mt r square multiplication omega t square, which is equal to 1 by 2 multiplication 120 multiplication 2 square multiplication 3 square. So it will be equal to 1080. Now I can write the value of kinetic energy P3, kinetic energy
And there's our current.
is equal to 1 by 2 ITP omega TP square, which is equal to 1 by 2 multiplication 1 by 2 MP multiplication R square plus MP multiplication R square omega TP square. So this value will be equal to 1 by 2 R square multiplication 1 by 2 MT plus MP multiplication omega TP square. So on solving it further, it will be equal to, so this value will be equal to 1 by 2 multiplication 2 square multiplication 1 by 2 multiplication 120 plus 70 multiplication 18 by 13 whole square. So finally we will get the answer as 498.462. Now friction does work. Friction does work. Friction does work. Friction does work. Negative. So friction does work. Negative. Negative work done by the friction. Increasing parachute velocity. Increasing increasing
400
para
F
velocity velocity. So if you call a people energy log to his cases, so I can write down if column of the table of the
So the world gets about
energy
80%
loss,
energy from
energy is lost,
fossil
energy
fuels.
loss,
It's everything from natural gas to oil to petroleum, just essentially carbon that's been compressed by the earth. It came from biomass a long time ago.
Ask F
So you really do need to read the last sentence, which says that x equals y. And so this is a very simple problem. Like 9 harder. Energy. So this is an 8 millimeter long, 8 meter long cube. They have actually so yeah, and correspond to the energy of the electron.
So what are x and y? Understanding that x and y are the same thing. So,
And we just need to look, we don't need to we just want to look at a simple atom. So this is the ionization energy in terms of joules.
so that's just going to be 6 minus 25.
Take
39 equals 2x squared.
Divide that by and to get it into
19.5. Solving that, I get x equals y, which is
to do that, we should get an ionization energy of about 1,000 So based on this calculation of ionization energy including kilojoules per mole, we look at H2 down here. We're going to do a very similar thing, except instead of using 2.18, we use 2.51, because that will lower
so again, drawing the diagram and figuring out what it means
we want to know the
most of the battle.
To get it to 0. So the energy of the
Y,
-2, we have to add to get it up.
X, and we continue to Z downward.
Same calculation as
We're given F1.
you see the ionization energy goes up, which
appears to have no x component.
and now we want to look at
So that's going to be
bond energy is different.
so it's a 3, 4, 5
And the 2 electron
triangle, but it's got no x component.
and again, obviously, consistent information.
Okay,
So we need to know the difference.
F1
minus
F2 has all 3 components.
of the B and then we want
That's going to be convenient.
we want to double that because
The angles are directly 3, 4, 5 triangle, but it's got no x component.
and now we just do what we normally been doing
I guess because okay. And the angle on y is 120. So yeah, they're all directly given.
Avogadro's number.
So let's go ahead and do
The bond
F1.
energy is about 300.
F1 in the x direction is 0.
So part D,
F1 in the y direction is, well, it's going in the positive y direction, 3/5
it wants us to look up the bond energy
of 450.
That
Well, 45 divided by 5 is 9. 9 times 3 is 27, so that's going to be 207 newtons in the positive direction. F1V is going to be 4/5 of 450, but it's in the negative direction. So that's going to give us negative 60.
And by coming off,
So let's move on to F2. This is actually all pretty straightforward. F2
would be the difference. The difference we have.
similarly we can take y direction.
is just going to be the 525
difference
and the cosine of x direction F y is 525. Cosine of the y direction what? 120 degrees. And F2z is just going to be 525.
Now
Cosine of z, which is 60 degrees. So this y one should end up giving us a negative number. The other one should be positive. So let's put them into a calculator.
For SP3, it's going to be very exaggerated.
525,
P and cosine of
25, 371.2.
So essentially, you know, S orbital, completely symmetric.
525 cosine of 120.
Completely asymmetric. And so the more degree P has,
Negative 262.5 newtons.
the fewer
And 525 cosine 60 is just going to give us 262.5. Okay, so now we have to add them together. Adding the x components, well, there is only one x component. So that's going to be, so I'm going to write it in vector form. 371.2i.
no lone pairs on carbon.
F. So now I'm going to do 270 minus 262.5. I don't trust myself, so I'm just going to do 270 minus 262.5. 7.5. Thought so. Plus 7.5j. And then in the k direction, we've got negative 360 plus 262.5.
That increasing atmospheric carbon dioxide. And then what's the source of it almost seems like
negative
most people
97.5.
that carbon dioxide is an important issue as it relates to climate change. Carbon dioxide is a greenhouse gas.
We need to sketch the vector and find the magnitude. So sketching the vector is what I will do next. We've got 371 in the I
Light reaches us.
Then we've got
And the green
7.5,
there,
which is almost
the
nothing.
atmosphere that we have.
In the J direction. And then we've got a negative K direction. So it's going to be like down over
And what this
there.
does
Maybe something like this.
is trap some of that heat in that atmosphere so that we can use our water as liquid.
So now,
And the way that it does that is a couple different ways. But one way is just that with the gaseous molecule in the they
371.2 squared plus 7.5 squared plus negative
some chemicals in particular
97.5
allow light to, such as carbon dioxide, allow light to
calculator.
go out. They're very translucent, but then they absorb that. And because and having a stable climate is something we're going to do. What's the source of this? This is not a big deal. For the last 200 years of the Industrial Revolution, humans have drastically and exponentially increased the amount of carbon dioxide that we put in our atmosphere, consumption, and combustion of fossils. There are other natural things like forest fires and volcanic activity, but the vast majority of
Theta and gamma are going to be very much the same.
the combustion of fossil fuels refers to generation of about 80% of our energy production. So it's something that's
So the world gets about 80% of its energy from this broad group category called fossil fuels. It's everything from natural gas to oil to petroleum, just essentially carbon that's been compressed that came from biogas 97.5.
First, we will find its magnitude, which will be equal to square of x.
Now I'll check the
Square of y equals to x square of magnitude of velocity at this point, having the value.
This question was given
Alright, now for the easier question, we need to figure out the coordinate direction angles for F1. So that's going to be, hey now, that's right, alpha,
So the first part has the ionization energy of hydrogen.
beta 1,
And we just need to look
and with the z direction,
just want to look at atoms, and they give us the ionization energy
alpha 1 will be the inverse cosine. Oh, wait a minute. I forgot to get the magnitude. F1, oh wait, we know the magnitude, it's 60. Silly me.
And to get it into we need to multiply by alpha.
Alpha 1 is the inverse cosine of F1x, which is negative 19.313 over 60.
So based on this calculation of ionization energy of H2 in kilojoules per mole, we look at
Just 19.3.
very similar thing, except the 2.18 we use to 25.1 is that we're
And gamma 1.
Another thing to note is that we're going to be ignoring the sun. We want to know that we want to know the energy that we have to add to
Negative 46.
to get it to zero. So the energy of the orbital is negative 2, then we have to add it to get it up to zero.
So just putting them into
And the
a
exact same
calculator
gives me one. You see the ionization energy goes up to now we want to look at the bond energy. The bond energy is the between the energy of the two electrons
124
and the two electrons in the and again, obviously,
is 19.3.
information into So we know the difference here. It's going to be
Negative 46.
minus
0 minus 1
and then we want to double the energy. And we want double that because
Welcome to the channel where we complex questions and break them down into simple step-by-step solution that help this problem together.
Now, at least this diagram seems easier to see. It's a little bit harder to interpret. Let me go ahead and draw. This is what I can draw here. Which I will draw on the y-axis. Let's try again. Okay, so continue this through. We've got a point B down here, which looks like the easy one. Definitely the easy one. There's a point A up here. And we're showing that this is 3. This is 4. This is 2. Guess that's it for that one. Oh no. This is 1.5. These are all feet. And then there's a point C back here. It's harder to visualize. But the hypotenuse is 2 feet and the angle is 20. So I'm going to, green, this, and I'm going to indicate that this is 2 cosine 20.
200 millimeters. Without sliding.
And this is 2 sine 20. Alright, so the distance from A to B, or U, is going to be, in the x direction is going 1.5 feet. In the y direction, it's going negative from 2 to 3, so it's only negative 1 foot.
Angular acceleration.
In the z direction, it's going down 4 feet.
In clockwise direction. Calculate acceleration.
AC. Is from A to C. A to C. So in the x direction, it's going backwards, so negative 2 sine 20. In the y direction, it's going over 2 plus 2 cosine 20. That would be positive direction.
Chapter 7, section 12. Why are scientists concerned about increasing atmospheric
And then in the z direction, it's just negative 7.
What's the source of it only seems like common sense. For most people, that carbon dioxide is an important issue as it relates to climate change because carbon dioxide is...
We need to figure out the resultant force. So, force AB is going to be FAB U vector AB over U AB.
And the green
so F AB
sounds like a
is going to be, let me put this into a calculator, FAB, which I did not write down yet, but the book tells us that FAB
some of that
is 20 pounds.
So that we can that our water is liquid and all that.
Times
And the way that it does that is
U vector AB. I'm going to use the x component, negative 2. Nope. It's AB, not CC,
thermally excited
which is 1.5
radiation coming from the sun. They'll stop that.
over the square root.
Some chemicals in particular
1.5 squared. What's 1 squared? What's 4 squared?
But then they absorb that heat. And because you're interested in having a stable climate, something
that gives me 6.84
over the last 200 years. Humans have drastically and exponentially.
I'll put negative 1 into the numerator.
Dioxide that we use in our atmosphere, consumption, and combustion. There are other natural
4.56 J.
things like forest fires.
Put negative 4 in the numerator.
The vast majority of carbon dioxide in the combustion of fossil fuels.
2K.
Accounts for the generation of about 80% of our energy production.
AC. So now the denominator becomes, well, first of all, FAC, according to the book, is 40 pounds. So it's 40 times. Now in the denominator, I'm putting...
So the world gets about 80% of its energy from this
negative 2 sine
fossil fuels.
20.
It's everything from natural gas to oil to petroleum to
cosine.
essentially carbon that's been compressed by the earth. It came from biomass a long time ago.
Plus 4 squared, 16. Alright, so the numerator is negative 2 sine 20. Give us negative 4.87. Now I'm going to put the 2 plus 2 cosine 20 in the numerator. 27.6. And now negative 4 in the numerator.
So the first part is about the ionization energy.
Now I need to add those together to get the result.
Just want to look at a single hydrogen atom.
6.84 minus 4.87. 1.97i 27.6 minus 4.56. 23.
I can write this expression as T is equal to
18.2 plus 28.5.
ionization energy of about 1,400
omega, which is other simplification.
And we're still not done.
calculation of ionization energy.
IT by
Look at H2.
Omega is
We're going to do a very similar thing, except instead of using 2.18,
This equation.
factors already we have written.
lower.
0.1
R squared by 1 by 2 M R
You want to know
squared
that
plus M
on solving it.
R squared
This velocity is
omega t.
To get it to
So finally
minus
on
1
other
point
simplification
I
you can
cap
calculate was omega
minus
dt
1
is equal to mt by
If
mt
P2
plus
going to
mt
9,
multiplication omega t. So it will be equal to 120 by 120 plus 2 multiplication 70 kg multiplication 3 radian per second. So you will get the value as
not pounds.
7 point,
velocity of
sorry, it is equal to 1.3846 approx
Check if that's the correct answer.
1.385 radian per second. Now I will
Yes, it is.
simplify part B of this problem. So in part
And
B, I
then
will
to
use
get
the
alpha,
formula
beta, and gamma, we just use the
T
inverse
is equal
cosine
it is equal to 1 by 2
of FR X, which is 1.97, over FR, which is 52.1.
mt multiplication r square multiplication omega t square which is equal to 1 by 4 mt r square multiplication omega t square which is equal to 1 by 4 multiplication 120 multiplication
Now we just do
square multiplication 3 square
7.83.
now I can write the value of
Is that
kinetic
the
energy
numerator
kinetic
to 23?
dp is equal to 1 by 2 ITP omega
Gamma, I
t
change the
square
numerator
which
to
is equal to
negative
1 by 2 multiplication 1 by 2 mt multiplication r square plus mt multiplication r square omega tp square. So this value will be equal to 1 by 2 r square multiplication 1
those
by
are
2
correct.
mt plus mt multiplication omega tp square. So on solving it further, it will be equal to, so this value will be equal to 1 by 2 multiplication 2 square multiplication 1 by 2 multiplication 120 plus 70 multiplication 18 by 13 whole square. So finally you will get the answer as 498.46. Now friction does work. Friction does work. Friction does work. Friction does work negative. So friction does work negative. Negative work is done by the friction, increasing parachute velocity, increasing
about 9%.
increasing para velocity. So if he falls off the table, energy is lost to his gain. So I can write if he falls off the table, energy is lost, energy is lost, energy is lost to his gain, I hope you understand it.
Except the only difference is going to be as a result of the ways in which the asymmetry between these two lobes is exaggerated. So for SP3 it's going to be very exaggerated, SP it might be a lot so essentially, we can think of S orbital completely symmetric, P orbital like this, completely asymmetric, and to the more degree P it has, the closer it's going to look to this guy, and the fewer P orbitals it has, the closer it's going to be 93. And then how do we calculate everything correctly? We simply need to add up the number of atoms and the number of electrons.
This is only one part question.
And then compare that to how many orbitals mixed together. So, for example, if we have
Okay. This is really just a two-dimensional problem.
8.2
we have no lone pairs on carbon, especially things around it. That means we need to have orbitals that'll be 1s and 2
meter per second square.
So,
J cap.
On the pivot point,
Acceleration of v point. Acceleration of v point
negative 200.
Acceleration of V with respect to V. It will be acceleration of V plus acceleration of
Chapter 7, section problem. Why are scientists concerned about increasing
That was F2Y.
atmospheric carbon dioxide?
cross
What's the source of this increase? It
F2Y.
doesn't seem like common sense
substitute the value
for most people, and it is that carbon dioxide
acceleration of
is
V
important
in
as
brackets
it relates to
having the acceleration
carbon dioxide is
12.3 meter per
and
second
that term means something very
A
unique.
cap
So we live on
Negative
Earth,
100.
and
acceleration of G, angular acceleration of G minus A cap
and light reaches us.
VP minus
And
0.1
green there, the
I
atmosphere
cap
extends like a halo, a little bit into,
Okay.
the
G
result
cap
and what this does is trap some of that in that atmosphere
here I am
so that we can live. Water is liquid and all that kind of stuff. And the way that it does that is a couple different ways. But one way is just that with the gases in the atmosphere, if they are really excited to the radiation coming from the sun, they'll live. Some chemicals in particular allow light to, such as carbon dioxide, allow light to really well. But then they absorb that. And because we're interested in having a stable climate, it's something we're looking into. What's the source of this increase? This is not a debate. Over the last 200 years since the Industrial Revolution, humans have drastically and exponentially increased the amount of carbon dioxide that we use to our atmosphere due to consumption and combustion of fossil fuels. There are other natural sources as well that do things like forest fires and volcanic gas, but the vast majority of carbon dioxide comes from the combustion of fossil fuels. And combustion of fossil fuels accounts for the generation of about 80% of our energy production. So it's something to pay attention to.
Plus F1
acceleration of A
in the Y direction.
acceleration of V
Conclusion.
acceleration of
If
V with
F1
respect
and
to
beta
V
1 are 1,
About
that's what we're displaying. Beta 1 is going to keep.
So the world gets about 80% of its energy from this
and
raw chemicals we call fossil fuels. It's everything from natural gas to oil to petroleum, just essentially carbon that's been compressed by the earth. That came from biomass a long time ago.
substitute the value
To be
Conclusion. Closely
Negative 350 in beta.
this question was given a molecular orbital calculation for H2, and what about this is they've actually put in energy into all the orbitals and such.
alpha AB
Welcome to highs and lows, they have actual
A
numbers.
cap cross
So the energy is going to correspond to the energy of the electron in that.
I cap
So the first part asks us about the ionization of energy of hydrogen, so it's
In the XY plane.
and we just need to look, we don't need this molecular calculation, we just want to look at a single hydrogen atom, and they give us the ionization energy in terms of joules. This is just a unit conversion.
So just take 2. That doesn't make sense now.
So if we do the exact same calculation as part A,
alpha AB you will get
you see the ionization energy goes up to
1.11 in radian per
now we want
second
to look
square.
at the bond energy for H2. the bond energy is the difference between the energy of the two electrons on hydrogen atoms and the two electrons when they're engaged. And again, not to say it's just the information.
That far.
So we have the difference here. It's going to be 1 minus 2.18. And that's still going to be times 10 to the minus 18. And then we want to double that. And we want to double that because there's 2 electrons.
12.98
gets lowered in that.
per second square. So answer
And
of
the reason why is that I'm not sure that I know the relations
Normally been doing between
12.98 per second square long. That's all for this problem.
Gauss's number.
and
We
gamma.
see the bond energy is about 397. So for part B, she wants us to look up
So I looked back in the book
answer.
and I noticed that
It wants us to look at the bond energy of table 503. That bond energy is
the cosine squared of theta,
it gives us an energy of 630. So how is calculated bond energy? Well, it's
now I know.
percent difference is going to be
Let's call this as our point C, our point D,
and then
Anyway,
that would be the difference.
figure
and we have
Percent difference
y component and x component, and these are
we
the
get percent
reactions,
difference
and the reaction
And so,
let's call it as dx.
about 9%.
The water pressure exerted by
I need to find
and the water pressure exerted by
one.
let's call this pressure A, pressure B, and the force resultant of the pressure let's call this F, and the force resultant of the energy which is FP. So let's determine our
We're talking again about SP as
gamma is equals to gamma
it's
So we're saying that negative 350 is not one because also comes down to 1.
times the height of the water.
Cosine
the difference
So we have
gamma.
3.43
asymmetry between these two
kilo
modes.
Pascal.
So for SP3 it's going to be very exaggerated. For SP it might be a lot.
We have 1,000
SP2. So essentially,
which is
S orbital,
19
weakly symmetric P orbital like this.
So now we can determine the FP,
And so the more degree
for
P
FA
has,
we
the
have
closer it's going to look.
volume of this,
Oh, wait a minute.
water pressure.
Fewer P orbitals
So
it
we
has.
have 1/2 multiplied by the base, which is 29
And then everything correct. We
times
simply
the
need to
height
add up the number
times
of
the
atoms and the
length
number
of
of
the
electrons.
which is equals to